Good evening, this is Kavipriya, Assistant Professor, EC Department. I am going to discuss about the topic pulse communication. We're going to see what is this pulse communication, and we're going to see one of the type of pulse communication, which is nothing but PAM, pulse amplitude modulation. So first, what is this pulse communication? So pulse communication is nothing but it is one of the modulation technique where information is transmitted using a series of pulses which can vary in different properties such as amplitude, width, position or code. These are fundamentals in digital communication systems, and it is essential for converting the analog signals into a digital form. The three key types of pulse communication are pulse amplitude modulation, pulse width modulation, pulse position modulation. So first we're going to see what is this PAM or pulse amplitude modulation. It is a key modulation technique used in digital communication for transmitting the analog data, and it is one of the most widely used type of analog to digital conversion. It is a process, the process of this is very simple, where the amplitude of sequence of pulses changes with the instantaneous amplitude of the analog message signal. The analog signal that has to be modulated is sampled by the sequence of pulses that are amplitude modulated on the carrier to produce the amplitude modulated pulses. And this is a diagram. This is a message signal, carrier signal, and the modulated carrier signal. So next we are going to see about the pulse amplitude modulation block diagram. So pulse amplitude modulation is a modulation technique where amplitude of the series of the pulses is varied in accordance to the amplitude of the analog signal that is being transmitted. So the modulating signal is first passes over the low pass filter and is given to the multiplexer. So the multiplexer, the other input is a pulse generator. So both are combined and it is given to the modulator. So the output of the modulator is a pulse amplitude modulator signal, PAM signal. So first one is a sampling. So periodically the analog signals are being sampled. These are called sampling intervals, and the analyzing of these has no chance if we put a condition for the sampling rate. We all know the Nyquist criteria. Fs should be greater than or equal to twice the maximum frequency. So sampling frequency should be greater than or equal to twice the maximum frequency. If this condition is being satisfied, then there will be no chances for the aliasing, overlapping of a signal. Second one is a quantization. Each sample is provided with the quantized amplitude. Third one is a modulation. Since each sample quantization level constitutes the amplitude of the generated pulses, only single pulses are produced if every sample is integer. So often the pulses does not change its width. With its amplitude can adopt any of the qualified sample values. And next is a transmission through the medium of transmission. So the carrier, for example, if it is a visual analog signal or digital one, is being represented as a pulse chain that is being modulated. It can be transmitted through a wireless or wired pathway depending on the framework of purpose that lies behind it. And next is a reception. The reception results in amplitude modulation, which then undergoes a process of demodulation. Next one is a reconstruction. By summation of different orders of magnitude outlined in the given position, the lower frequencies are undermodulated and finally rebuilt into a continuous signal. This also means that it is used for the interpolation. And finally passed to the filtering. A low pass filter is generally employed to take out the high frequency components from the smooth recovered analog signal, which meanwhile preserves the original analog signal component. And next is a pulse amplitude demodulation. So the PAM signal passes to the reconstruction filter and finally it is given to the equalizer. From the equalizer we will be getting the original signal. So extracting the original signal from the modulated signal is a demodulation process of the pulse amplitude modulation. And next, what are all the applications of the PAM? To send the digital data over the phone lines and through digital subscriber line, modem, everything uses this PAM. Pulse code modulation is used in the audio CDs to encode the analog audio signals into the digital form. Digital data is sent across optical fiber using this PAM in fiber optic communication. Physiological signals are sent over PAM in biometrical signal processing, including electrocardiography. Pulse width modulation techniques are used in PAM based industrial automation system to control the motor speed and position. And what are all the advantages? It is inexpensive and simple to integrate. It facilitates the transfer of analog signal via digital communication channels without compromising the quality. PM transmits the analog signal over a digital communication network with ease. PM is simple, it has strong noise immunity and can withstand noise interference both during signal transmission and reception. Simple signal processing methods like filtering and demodulation are made possible by the PAM, which make it possible to efficiently extract the information from the modulating signal for variety of applications such as audio transmission and telecommunication. Drawback is that AM is susceptible to amplitude changes which can reduce the signal quality and causes the information loss during transmission, particularly when noise or channel distortion is present. Compared to other modulation, PAM demands a larger bandwidth which results in a lower efficiency. PAM has a reduced signal to noise ratio, especially in high noise setting where background noise can obstruct the signal and reduce the accuracy and dependability of data being transmitted. So it's all about the modulation process involved in pulse amplitude modulation and demodulation process, and what are all the applications of PAM and what are all the advantages and drawbacks of PAM, and also we have seen what is this pulse communication. Thank you.